Welcome back. In our last class, we have already started solving problem sums based on an important concept of school level mathematics, which is time and work. This is our second class, and in today's class also we will be solving different types of problem sums. So let's get started. The first problem sum says A can do a piece of work, a particular work, in 40 days. B, the same work B can do in 45 days. Now, if they work together for 10 days, so together they have started working and they continue for 10 days, and after that B goes away. Means after that B leaves that work and A completes the remaining work. So we have to find that when B goes away, then how many days A will take to finish or complete the remaining work. So here work is constant and A completes the same piece of work in 40 days. So in one day, how much A will do? A will do definitely 1 by 40, 1 out of 40. If the whole work we assume that as 1. The same piece of work B completes in 45 days. So in one day, how much B will do? B will complete 1 divided by 45, 1 of 45. Again, the whole work has been taken as 1. Now, if A and B, they start working on that same piece of work, then they completes in one day how much work? A individually complete 1 by 40 and B individually completes 1 by 45, this much work. So when they will work together, it will be the combined effect of both of them. So their effect will be added. The portion that they complete in one day, those values will be added here. So here we have to simplify this. So we have to take the LCM of the denominators. So finally it will be 17 divided by 360. This much work A and B together complete in one day. So A and B in 10 days, how much they will complete? In one day, if they do this much, then in 10 days definitely it will be 10 times of the work that they complete in one day. So 17 divided by 360, so it will be 10 times. That means in 10 days they will complete 17 divided by 36, this much work. Now after 10 days what happens? After 10 days B leaves that work, B goes away and A has to finish the remaining work. So what we have to do is we have to find the remaining work. So the total work or the whole work is 1 and this much they together have completed in 10 days. So the remaining work will be 1 minus 17 by 36. So if we simplify further, then it will be 19 divided by 36. So this much work now A has to finish alone. Now A completes the whole work. Whole work means I have assumed 1 and A completes the whole work in 40 days. I am not writing the full sentence. Here I am only explaining the logic, but you must write the full sentence to explain or express properly. So A completes the whole work in 40 days. Now if A wants to complete this much work, 19 by 36, and 19 by 36 we know that this is less than 1 because 19 numerator is less than denominator, which is 36. So if the whole work is completed in 40 days, then a portion of that work which is less than the whole work, definitely to complete that work the time that will be taken will be less than 40 days, which is the time to complete the whole work. So 40 will be multiplied by 19 by 36. Like when we multiply 20 by 2, then it becomes 40. Means 40 is more than 20. But when we multiply 20 by half, then it becomes 10. And 10 is less than 20. Why 10 is less than 20? Because we are multiplying 20 by a factor which is less than 1. And here 40 is more than 20. Why? Because we are multiplying 20 by a factor which is greater than 1. So here to complete the whole work, if A needs 40 days, then to complete a part of that work which is 19 by 36 and which is less than 1, means which is less than the whole work. So the time or number of days that will be required will be less than 40, and that's why we will multiply 40 by this 19 by 36, which is less than 1. So finally it will be 190 by 9, or 21 and 1 by 9 days. So to complete the remaining work, A will need these many days, 21 and 1 by 9 days. So this is how we simplify. Now we will see what is the next problem. The next problem says that A and B can do a piece of work in 6 days and 4 days respectively. Again, the work is fixed, the piece of work. A started the work and worked at it for 2 days. Okay, fine. And then he was joined by B. Now find the total time taken to complete the whole work. So A completes the whole work in 6 days. That means in 1 day A will do how much? It will be 1 by 6. By now we know how it is done. B completes the same piece of work in 4 days. So in 1 day how much B will do? B will do 1 divided by 4. So when A will start the work and will work for 2 days, so now if we find that in 2 days how much A does? A does, if one in 1 day, if A does 1 by 6, then definitely in 2 days he will complete, or he will do twice of that work. So it will be multiplied by 2. That means in 2 days A completes this much work, 1/3, and after 2 days B joins A. So and then after that they work together to finish the remaining work. So we have to find that what is the remaining work when A has already worked for 2 days on that. So remaining work will be, if the total work is 1, and if A has already completed 1 by 3 or 1/3 of that whole work in 2 days, then the remaining work will be 2/3 or 2 by 3. Now this remaining work will be completed by A and B together. So A and B, when they work together, then in 1 day how much work they do? A alone does 1 by 6. This is the value that we have seen, and B alone does 1 by 4. So when they will be working together, then in 1 day they will complete. We have to simplify this. So it will be, the LCM of the denominator will be 12. So it will be 2 and it will be 3. So 5 by 12. This much work. Again, I am not writing the full sentence. You must write if you need. So in 1 day A and B together will complete 5 by 12, this much work. So now we have to find that to complete this much work, 2 by 3 or 2/3, how much time they will take. So 5 by 12, this much work A and B, they together complete in 1 day. So if the whole work they want to complete, then how much time they will take? 5 by 12 is less than 1. So it is a portion of the work that they complete in 1 day. Now if they want to complete the whole work, definitely the time that will be taken by them, that will be more than 1 day, because 5 by 12 is less. So if they want to complete the whole work, the time will be more. So here it will be 1 divided by 5 by 12, or directly we can write 12 by 5. So 12 by 5 is the number of days that A and B together will take to complete the whole work. But they are not doing the whole work together, rather they will be completing only 2/3 of the work. So to complete this much work, 2/3, how much time A and B together will take? So to complete the whole work, which is 1, if they take 12 by 5, this many days or this much time, then to complete a portion of that work, which is less than 1, 2/3 is less than work, then the time that they will take will be less than 12 by 5. So 12 by 5 will be multiplied by a factor which is less than 1. Here 2 by, it will be multiplied by 2 by 3, not 3 by 2. So finally if we simplify this, it will be 8 by 5. So to complete the remaining work, they will take 8 by 5 days. But the question was, find the total time taken to complete the work. So 8 by 5 is the time that they will take to complete the remaining work, which is 2/3, this much work. But B has already worked on that to complete 1/3 of the work, and he has already taken 2 days. So this 2 days will be added because we want to find the total time that they have taken to complete the whole work. First, A has alone worked for 2 days, and then A and B have worked together. So the total time will be, if we simplify this, then it will be 5. Here it will be 8 and then 10. So it will be 18 divided by 5 days. So it will be 3 and 3 by 5 days. Now we'll move on to the next problem sum. It says that if 12 boys earn rupees 840 in 7 days, then what will 15 boys earn in 2 days? So here the difference of this problem with the other problems is, here we have two variables. Here one is number of boys, that is one variable which is varying, and the number of days, that is another variable which is varying. And based on these two values, number of boys and number of days, we will find the amount, the rupees that they will earn. Definitely that is also variable, but the value of that variable we will find based on two other variables. So here we can frame this problem like, again I am not writing the full sentence. So 12 boys, when they work for 7 days, how much money they earn? They earn rupees 840. So if one boy work for 7 days, now I am keeping the second variable, number of days, constant or fixed, and I am varying this variable. So if 12 boys say in 7 days they can earn rupees 840, then for 7 days if only one boy work, then how much money he will earn? Definitely it will be less than the amount which was earned by 12 boys, because 12 boys, the amount or the money that they can earn, definitely if one boy work, then it will be much less than that. So it will be 1/12 of that amount. So it will be 840 divided by 12. That is the amount earned by only one boy in 7 days. Now I will vary the second variable. So one boy, when he will work for only 1 day, how much money he will earn? So if one boy in 7 days, if he earns 840 divided by 12, this much rupees, then if that boy works only for 1 day, definitely the earning will be again less than the value that he earns in 7 days. So it will be 1/7 of this amount, the total amount that he earns in 7 days. So in 7 days he earns 840 by 12, this much amount. So in 1 day it will be 1/7 of that. So this will be the amount that one boy earns in 1 day. So if we can further simplify this, so it will be only rupees 10. Now the question is, if 15 boys work for 6 days, then how much they will earn? So now we have framed the problem with respect to one boy and 1 day. So if now 15 boys work together for 1 day, then how much money they will earn? So if one boy, he works only for 1 day, then he earns rupees 10. So now if 15 boys work for 1 day, amount of work definitely will vary. So the amount that will be earned by them, that will also vary, and it will be 15 times. So one boy earns 10 rupees in 1 day. So when 15 boys will work, then in 1 day the amount that will be earned, it will be 15 times. So it will be 150, this much rupees. Now if 15 boys, they work for 6 days, then how much money they will earn? So in 1 day if they earn 150 rupees, and if they again work together for 6 days, then it will be definitely 6 times of the amount that they earn in 1 day. So it will be 900 rupees. So this is the answer, and this is how we simplify this type of problem. Now we will solve similar kind of problem next. So again, if 9 girls can prepare 135 garlands in 3 hours, then how many girls are needed to prepare 270 garlands in 1 hour? So here we have three variables. One is number of girls, the second one is time, which has been expressed in hours, and the third variable is number of garlands. Now in the first problem the number of garlands was 135, and that was prepared in 3 hours, and that was prepared by 9 girls. In the second statement, 270 garlands were prepared, and they were prepared in 1 hour, and they were prepared by how many girls, that we don't know. So that is unknown to us. Now here we can see we have 3 variables, and based on these 2 variables, garlands and the time, we will be finding the number of girls. So we can frame the problem this way, that 135 garlands are prepared in 3 hours by how many girls? By 9 girls. So again I am not writing the full sentence. So if in 3 hours only one garland needs to be prepared, then how many girls will be needed? Definitely it will be much less than 9 girls. So it will be 9 divided by 135, which is less than 9. Now if one garland needs to be prepared in 1 hour, then how many girls will be needed? Just understand clearly. If 135 garlands needed to be prepared in 3 hours, then we needed 9 girls. So if only one garland needs to be prepared, again the time is fixed. So how many girls we need? The manpower will be less than that. So the requirement will be less than 9 girls. That's why I have divided 9 by 135. Now the same garland, when it was prepared in 3 hours, this many girls we needed. But when the same amount of work we need to do in less time, then the manpower will be increased. So instead of 3 hours, now the same garland, if we need to prepare in 1 hour, means in less time, then the manpower will increase. So 9 divided by 135 will be multiplied by 3. Now the requirement is, if 270 garlands needs to be prepared in 1 hour. So 270 means again the amount of work is increasing. So if amount of work is increasing, then the manpower will increase. So 9 divided by 135 multiplied by 3, this was the manpower when one garland was prepared in 1 hour. Now in 1 hour, we need to, or we want to prepare 270 garlands. So here the work is increasing. So if work is increasing, then the manpower will also increase. So we will multiply by 270. So it will be 54 girls. And as we know that work is directly proportional to time, and work is also directly proportional to resource. More work means to complete that work we need more time, and more work means to complete that work we need more resource or more manpower. Now to complete the same piece of work or particular work, if we increase the time, then the number of resource that will be required, it will be less. And thus to complete the same piece of work, if we decrease the time, then the number of resource that will be required, it will be more. On the other hand, we can say that to complete a particular work, if we increase the resource, then the time that will be taken to complete that work, it will be less. And to complete the same piece of work or particular work, if we decrease the number of resource, then the time that will be taken, it will be more, or the time taken, that will increase. So it will be 54 girls. Now as we know that to complete a work, the time that is taken is directly proportional to the amount of work. Now if we increase the amount of work, then the time taken will, or time needed will be increased. Similarly, the resource or the manpower that needed to complete a particular piece of work is directly proportional to, so it is 54 girls. And as we know that to complete a particular work or particular piece of work, time needed is directly proportional to the amount of work, and also the resource needed, that is also directly proportional to the amount of work. So if we increase the amount of work, then time needed will be increased, and vice versa, and same is applicable for the resource also. But if we have a piece of work and if we have two variables like time and resource, and if we want to complete the same piece of work and if we increase the time, then the amount of resource that will be required will decrease, and if we increase the resource, then the time that will be needed to finish a particular work, that will decrease, and also vice versa. Now we will move on to the next problem sum, and it says that working for 8 hours a day, Anshu can copy a book in 18 days. So here work is copying a book, and here we have two variables, number of hours and number of days. So how many hours a day should he work to finish the same amount of work in 12 days? So both the cases the number of days are known, but the number of hours is known for one case, and for the second case it is not known, that we have to find. So we can frame the problem this way, that our work which is fixed, which is copying a book, if Anshu wants to finish that work, and if he finishes that in 18 days, then per day he needs to work for 8 hours. So, if the same amount of work Anshu wants to finish in one day, here we are increasing the time. So, if instead of 18 days, if someone wants to finish the same work in one day, that means he needs to work more hours per day. So, here it will be 18 multiplied by 8. So, these many hours Anshu needs to work per day, because instead of 18 days, now he wants to finish that work first. So in a single day he wants to finish. Now again the same amount of work, if Anshu wants to finish in more days, in more number of days, in 12 days, then how many works he needs to work per day? So here, see, now we are increasing the time span, the number of days. So here the number of hours that Anshu needs to work per day will decrease. So it will be 18 multiplied by 8, that was the time, or that was the number of hours needed to finish the work in one day. Now since we are increasing the number of days, so the time or the number of hours needed per day, that will decrease. So it will be 12 hours. Now if Anshu wants to finish the same amount of work in 12 days, then he needs to work 12 hours per day. So this is one way to simplify or solve this type of problem sum. And also we can simplify this by applying the concept of variation. Now here, as we can see, we have two variables, number of days and number of hours. So in the first problem, in the first statement of this problem, we can see here that the number of days is 18 and number of hours is 8. And in the second statement, we have number of days 12, but we don't know that number of hours, so that we will assume as unknown variable x. Now here, since we are decreasing the number of days, definitely the number of hours per day, that requirement will increase to complete a particular work. So here the relationship between these two variables is inversely proportional. So inversely proportional means if we have suppose two variables a and b, and if they are inversely proportional, then we know this is the relationship. So a will be equal to k by b, or we can say ab will be equal to k. So we know in case of inverse variation, the multiplication of two variables is always constant. So if number of days we assume as one variable a, and number of hours if we assume as another variable b, then the multiplication of, so we know this relationship also, a1 b1 will be also equal to a2 b2. Always the multiplication of these two variables will be constant. So here so a1 will be what? A1 will be 18 and b1 will be 8. So 18 multiplied by 8 will be equal to a2 will be 12 and b2 will be x, right? So from here we can find the value of x, and that will be 18 multiplied by 8 divided by 12. So it's simple. So again we are going to get the same result, which is 12 or 12 hours. So this is how we can also apply the concept of variation or inverse variation here. And we know that the problem of time and work, they are actually implementation of direct variation and inverse variation only. So this much for today's class. In the next class we will be solving a few more problem sums. Till then, stay safe and stay healthy. Thank you.